Bismillahirrahmanirrahim. Dear students, today our topic is magnetic force on a current carrying loop. In the previous lecture, we have discussed that when a current carrying wire is placed in a magnetic field, then it experiences a force, or you can say that a force is exerted on the wire. And today we will place a current carrying loop or a loop of wire inside a magnetic field, and we will see that what will happen. So here the experimental arrangement of this topic is shown here in the figure. You can see that we have a magnet, north and south poles of the magnets, and the lines originates from the lines or magnetic field lines originates from north pole to south pole. Here this arrow sign indicates or shows the direction of magnetic field lines, and we have a loop of RSPQ. We have a loop of wire which is placed inside the magnetic field, and this loop is connected with the battery. When it is connected with the battery, then this current will start to flow through the loop by entering from one end of the loop. Like here you can see the current is entering from this end of the loop and leaving the current from the other end of the loop, and from this end of the loop the current will leave the loop. So here in this way the current will flow through the loop in a direction RSQP. Now if we look at to the loop, this loop has two sides. The first one is RS side and the second one is PQ side. Now we will discuss both of these cases. When the current flow through RS side of the loop, what will happen, and when the current will flow through PQ side of the loop, then what will happen. So first of all we are going to discuss RS side of the loop. So here you can see that when the current flow from R to S, the direction of the current is upward. We will apply Fleming left hand rule to find the direction of the force, because this is a wire and it is placed in the magnetic field and the force will be exerted on this wire. So by applying Fleming left hand rule, we will find the direction of the magnetic force or the force acting on this wire. So that is, place your first finger or forefinger in the direction of magnetic field lines, the middle finger in the direction of the current, then the thumb will show the direction of the force. So place it here, like it will be like this. You can see that the field lines is from north to south, from left to right, and the current from down to up. So the thumb will indicate the direction of the force which is inward to the screen or inward to the page. So when the current flow from down to upward, the force will be inward. And now we will come to the PQ side of the loop. So here the magnetic field lines is from north to south and the current is flowing from up to downward. So place your forefinger in the direction of the field, the middle finger in the direction of the current. Like here the force will be acting upward. In RS side the force is acting inward of the screen, and at PQ side the force is acting outward of the screen. As these forces are equal in magnitude but opposite in direction, so they will form a couple, and the resulting torque will be produced. Torque is defined as the rotational or the turning effect of the force is called torque. So here if you can see that one force, the direction of one force is inward and the other one is outward, this coil will start to rotate. So the force producing the rotation, that is called torque. And that torque depends upon two factors. The first one is the current flowing through this loop. Means if we increase the amount of current flowing through the loop, then the torque produced on the loop will be larger. And if the current is flowing through the loop is smaller, then the torque will be also small. And the second one, the number of loops placed in the magnetic field, means like here we have just one loop. If we place it more than one loop, then it will produce more torque. So with the increasing the number of loops, the torque will also be increased. And one thing more, this was the basic foundation for the discovery of electric motors. Means the electric motors also work on this principle. We place a loop inside the magnetic field, and when the current flow through this loop, it will rotate. This is also the basic principle, working principle of electric motors. So dear students, this was all about magnetic force on a current carrying loop. If you have any question, you can ask in the comment. And our next session will be about electric motors. We will discuss the electric motors. Till next session, have a good time and take care of yourself. Thank you for watching.